when using the first in first out page replacement algorithm. Belady's anomaly. Consider the following example of the if-I-if-O algorithm. Number of frames allocated equals 3, reference string 1, 2, 3, 4, 1, 2, 5, 1, 2, 3, 4, 5. Number of page faults equals 9. Now, an initiative idea is that we increase the number of frames allocated to 4 from 3. The page faults should decrease. But the following example demonstrates otherwise. Number of frames allocated equals 4. Reference string 1, 2, 3, 4, 1, 2, 5.
Stack replacement algorithms. These are a class of page replacement algorithms with the following property. Set of pages in the main memory with n frames is a set of pages in memory with n plus 1 miss. These algorithms do not suffer from Belady's anomaly. An example is the LRU algorithm. Consider the following examples which shows that LRU does not suffer from Belady's anomaly. For the given reference string, number of frames allocated is equal to 3. Reference string 1, 2, 3, 4, 1, 2, 3, 1, 2, 5, 1, 2, 3, 4, 5. Number of page faults is equal to 10. Number of frames allocated is equal to 4. Reference string 1, 2, 3, 4, 1, 2, 5, 1, 2, 3, 4. Few computer systems provide sufficient hardware support for true LRU page replacement. Some systems provide no hardware support and other page replacement algorithms must be used. Least frequently used algorithm. This algorithm is based on the locality of reference concept. The least frequently used page is not in the current locality. LFU requires that the page with the smallest count be replaced. Next is most frequently used. The MFU page replacement algorithm is based on the argument that page with the smallest count was probably just brought in has yet to be used. It will be in the locality that has just started. Page buffering algorithm. The OS may keep a pool of frames. When a page fault occurs, a victim page is chosen as before. However, the desired page is read into a pre-frame from pool before the page is written out. Next, local versus global replacement. A process P generates a page fault. Page can be selected in two ways. First is select for replacement one of its frames. Second, select for replacement a frame from a process with the lower priority number. Global replace allows a process to select a replacement from frame the set of all frames even if that frame belongs to some other process. One process can take a frame from other. Next is local replacement. Requires that each process select from one its allocated frames. Next is allocation of frames. Each process needs a minimum number of frames so that its execution may be guaranteed or a given machine. Let's consider the MOV X and Y instruction. The instruction is 6 bytes long or 16 bytes offsets. I might span 2 pages. Also 2 pages to handle source and 2 pages are required to handle destination, assuming 6 bytes source and destination. Next is there are 3 major allocation schemes. First is fixed allocation. In this scheme, free frames are equally divided among processes. Second is proportional allocation. Number of frames allocated to a process is proportional to its size in the scheme. Third is a priority allocation. Priority based proportional allocation. Here is an example of frame allocation. Number of free frames 60 is equal to 64. Number of process is equal to 3. Process sizes P1 is equal to 10 pages. P2 is equal to 40 pages. P3 is equal to 127 pages. Fixed allocation. 64 divide 3 is equal to 21 frames per process and put in the pre-frames list. Proportional allocation. SI is equal to size of process. Pi S is equal to SI. M, number of free frames. AI is allocation for phi is equal to S times S. Divide S, open close parenthesis, times N. A1 is equal to 10 divide 177 times 464 is equal to 3 frames. A2, 40 divide 177 times 64 is equal to 14 frames. A3 is equal to 127 divide 177 times 64 is equal to 45 frames. Next is 2 frames are put in the list of free frames. Trashing. If a process does not have enough pages, the page fault rate is very high. This leads to low CPU utilization. The operating system thinks that it needs to increase the degree of multi-programming because it monitors CPU utilization and finds it to be decreasing due to page faults. Next is a process is trashing if it is spending more time paging, swapping pages in and out than executing. Trashing results in severe performance problems like low CPU utilization, high disk utilization, low utilization of others' I/O devices.